Greetings, science family. Today we're going to be covering something called the ideal gas law. Now we know that gas can be measured in a few different ways. Gas can be measured with pressure, gas can be measured with volume, gas can be measured with temperature, and also something we haven't tackled just yet in class, but gas can also be measured in moles, which is the amount. So if you look, majority of these letters in this equation that we're about to introduce are all measurements that you have been working with: pressure, volume, moles, and temperature. What this ideal gas law does for us is it allows us to have an equation so that we can predict, hey, if I know the pressure, the volume, and the amount of moles of gas I have, then I could solve for temperature by knowing that. So you might be thinking, well, that's great, but you haven't talked about one of the letters yet, and that letter is R. Well, I'm glad you thought of that. R is actually what we call a constant. A constant means it's going to be a number that we can look up and use in this equation, but it's something that won't really change with different problems. A constant is just a set number, a set value that we're going to plug into the equation. Now, the interesting thing about the R value is that depending on what the unit of pressure is, will determine which R value we use. So let's look into that. The R value can be one of three values. So whenever we're going to plug into the ideal gas law problem, because we know that everything, pressure, volume, temperature, all affect each other, we're going to need to figure out which R value to use. And it all is based off of the units for pressure. So let's take a look at these three R values. This R value is 0.0821. And look at the units. It's atmospheres, liters, moles, and Kelvin, and it's in a fraction. That's important. Remember, atmosphere is the units for pressure, liters is the unit for volume, moles is the unit for the amount, which is letter N in this case, and K is the letter or unit for temperature. So if you look and see, the constant here has all of the units for pressure, volume, moles, and temperature, or the amount and temperature. So it's the same for right over here for this R value, except instead of atmospheres for its unit, it has kPa, which is still a pressure, liters is volume, moles is amount, letter N, and Kelvin is T. So the R values, again right here, take a look, is now the only reason it's a different number is because of the units for pressure, which is millimeters of mercury here. That's your pressure. Liters, just like all of them, is volume. Moles is amount, which is N, and Kelvin is temperature. So depending on what the unit is for pressure will determine which value you use for R. It's that straightforward. So let me give you an example. If we're doing a problem here and pressure is in units of atmospheres, ATM, if that's the case, then we would use this R value of 0.0821. Why? Because if pressure is in atmospheres, we have to use this R value. Well, say pressure was in millimeters of mercury. Then that first R value wouldn't work. We would have to use this R value because it's the only one that has millimeters of mercury in there for the unit of pressure. So we can plug into this equation PV equals nRT, it's called the ideal gas law, in order to solve for a missing variable. I think the best way to do this is to jump into some practice problems. So let's do that next. Let's take a look at ideal gas law worksheet number 1, and let's do some example problems together. So remember, the ideal gas law is PV equals nRT, and we have that right at the top here. We also have our three different constants for the ideal gas law. Remember that the only thing that's going to determine which R value to use is if it's ATM, kilopascals, or millimeters of mercury. That's going to be the main reason. Remember, these R values are not equations. All of these units are just simply there so that when we do the math, things will cancel out. Remember, this is the equation. So let's get to it. Let's get started and get working and get more comfortable with the ideal gas law. So here's question number 1. If I have 4 moles of a gas, so right away that's my N value, and it's at a pressure of 5.6 atm, that's P. By the way, notice that it's an atm, so the R value that uses atm is 0.0821. And I have a volume of 12 liters. I want to know what my temperature is. So that's going to be my question. So let's use PV equals nRT in order to solve for this. So my P is 5.6. My volume is 12 liters, right? And this is a multiplication sign, sorry. My N value, which is moles, is 4 moles. My R value is going to be 0.0821. Again, why? Because this R value is the only one that has ATM, and that is what our pressure is in. So we have to choose that R value. And then our last step is T. So that's what we're going to solve for. So let's do that. If we start with 5.6 times 12, that's going to give us 67.2 is equal to 4 times 0.0821. When you multiply those together, you get 0.3284 times T. Let's get T by itself by dividing by 0.3284 to both sides, 0.3284. And when you divide those together, you end up getting temperature is equal to, because remember that cancels out, temperature is going to equal to about 204.6 degrees Kelvin. Now, you might be thinking, when we plugged in this constant, what happened to all of these different units, ATM, liters, moles, and Kelvin? Well, they all canceled out besides the Kelvin because that was what was left in our answer. So the reason all these units exist in these R values, in these constants, is this so everything else can cancel out and you're left with only the unit you need. But again, the only reason you use this R value as opposed to this one or this one is because of the units of pressure were in ATM, and this is the only one that had ATM. The other R values had kPa and millimeters of mercury, so we couldn't use them. So as long as you know your units for pressure, boom, you are good to go and you know which R value or constant to use. Let's move on to question number 2. If I have an unknown quantity of gas at a pressure of 780 millimeters of mercury, so that's my pressure, and notice my pressure's units are in millimeters of mercury, and the only R value that has millimeters of mercury is the 62.36. So I know I'm going to be using that one for this problem. I know my volume is 31 liters, and I have a temperature of 87 degrees Celsius. Remember, 87 is in Celsius. We need all gas problems in Kelvin, so we're going to take 87 plus the 273, and that's going to give us 360 Kelvin. So we just want to know how many moles. And remember, moles is amount, which is the letter N. So that's our question. So I think we have everything we need to plug into this problem. So let's do that. I'm going to switch up my color. My pressure, P to start with, is 780. My volume is 31, so P times V is good. My N, I don't know, so I'm going to leave that as a variable. My R value, we decided, since pressure is in millimeters of mercury, is 62.36. And my temperature, now that I converted it to Kelvin, is 360. All right, well, if we do our algebra and move forward, let's do our 780 times 31. If we multiply those two together, we end up with 24,180. It's going to be equal to N times, and let's multiply these two. 62.36 times 360 is going to give us a big number, 22,449.6. All right, now that we have that, how do we get N, the variable, all by itself? It's simple. We're going to divide both sides by the 22,449.6. to both sides. So we divide that. Sorry, I'm going to write into the other problem a little bit. 22,449.6. Those are going to cancel out. I'm going to be left with n by itself. And this is my last problem. So it's going to be 24,180 divided by 22,449.6. And the answer we end up getting is 1.08. Now, what are the units for n? Well, n is amount, and if you remember, amount means moles. So we're going to put MOL. That means this gas with all these different measurements, there must be 1.08 moles of that gas. And we used the ideal gas law equation to figure it out. Let's jump to number 3 here. If I contain 3 moles of a gas, so moles is my n value, in a container with a volume of 60 liters, so that's my V volume. The temperature is 400 Kelvin, that's my T. What is the pressure inside? So I'm looking for my pressure. We want to know the pressure in kPa, kilopascals. Ooh, that's a hint. If we need the pressure in kPa, we're going to have to use the constant that uses kPa, which is going to be 8.31. But now that we have that, we should be good to go. I'm going to move up our paper just a little bit, and that way we'll have room now to do our problem. Okay, so let's do PV equals nRT. First thing is P. We don't know pressure, so we're going to leave that as a variable. V is our volume, that's 60 liters, so I'm going to put a 60. nRT, N is 3 moles. R is our value. We know we're going to be using 8.31 from up top. Because we want the answer in kPa, we have to use the constant that has the units of the kPa. And then finally T, which is in 400, and since it's in Kelvin, I don't have to do any conversions. Now that I have that, I know I'm going to have P times 60 equals, and let's multiply all that out. 3 times 8.31 times 400 is going to give me 9,972. Now that I have that, I can divide both sides by 60, so P is going to be all alone. The pressure ends up being 9,972 divided by 60, which is 166.2. The question is what units? We wanted it in kPa. Are we sure we got it in kPa? Yes, because we used that constant of 8.31, we know that it has kPa in there, so we are confident in our answer. All right, so these are 3 examples of using the ideal gas law, friends. Walking through it with you, plugging into the equation, the ideal gas law is pressure times volume equals moles times the constant times temperature. PV equals nRT, the ideal gas law. Well, best of luck. Continue to work on these. Own in on your algebra skills and reach out if you have any questions. Be well.